In this video, we are going to be reviewing a bunch of different examples of how you can determine the limiting reactant of a precipitation reaction. So this is when you're given molarities or concentrations and volumes rather than masses or moles or something like that. So while you've seen this same skill before, we're going to review so that we can hopefully master limiting reactants from before while also applying it to a new scenario because we have concentrations. So 578 milliliters of 3.4 molar silver nitrate is mixed with 314 milliliters of 2.1 molar potassium chloride. What is the limiting reactant? Alright, so first thing we have to be aware of is just know that in that question, whenever you're given data for more than one reactant in the question, you have to assume that you're dealing with a limiting reactants problem. And that's always got to be your first step in stoichiometry, right? You have to actually perform the math. You can't just guess which one is the limiting reactant. You have to actually deliberately solve for it. So whenever you have two sets of data, so you have information for both reactants, we first need to figure out how many moles of each thing we have. So the moles of silver nitrate, first of all, we know that concentration equals, or molarity, because that also means molarity. Molarity or concentration is equal to moles divided by volume. So therefore moles equals concentration times volume. So the moles of silver nitrate are the concentration, which is 3.4 molars or moles per liter. Again, the reason why I can write that, M as a unit is the same as moles per liter. All right? Same thing. That's something we just got to commit to memory. So 3.4 moles per liter times 0.578 liters. Again, why am I doing that? It's because we can't use milliliters in this problem. So if we want to know what it is in liters, if we want to know what that is in liters, we have to divide by 1,000. Right? Because 1 liter is 1,000 milliliters. So that makes the moles of silver nitrate. We can solve for that on our calculators. 3.4 molar times 0.578 liters. So that means we're going to have 1.9652 moles of silver nitrate. Alright, but we found the moles of one thing. We need to find the moles of both reactants to be able to figure out which is limiting. So now we need the moles of potassium chloride. And again, we know that moles is concentration or molarity times volume. So that's going to be 2.1 moles per liter. Again, same, M equals moles per liter, it's the same unit, times 0.314 liter. And that equals 0.6594 moles of potassium chloride. Alright, so we figured out here the number of moles of silver nitrate and the moles of potassium chloride, but we're not done yet. We don't know for sure which one is the limiting reactant. So, to be able to do this, to determine the limiting reactant, we have to use stoichiometry, and we have to compare compare the number of moles, or the like mole ratio, so number of moles, of each reactant. We have to compare the number of moles of each reactant to the same product. We are going to set up our stoichiometry so that we compare the number of moles of each reactant to the same product. And that's what's going to tell if it's limiting or not. So I'm just going to choose, I think we'll do, let's just say silver chloride. We're going to make that be our product. So first, we'll see how many moles of silver chloride would be produced if silver nitrate was limiting. So we have 1.9652 moles of silver nitrate. And we know from the balanced equation, this one was simpler for us because everything's 1 to 1. We know that if we set up our stoichiometry, there's 1 mole of silver chloride for every 1 mole of silver nitrate in the reaction. So that means that if silver nitrate were limiting, we would get 1.9652 moles of silver chloride. Now we have to compare the other reactant to that same product, so potassium chloride. So that was kind of our first step. And then our second part here was, okay, we have 0.6594 moles of potassium chloride. And then we're going to set up our multiplier. So we know from this reaction, everything is 1 to 1. We know that there is 1 mole of silver chloride for every 1 mole of potassium chloride in this reaction. Which means that if potassium chloride were limiting, if that were the limiting reactant, then we would produce 0.6594 moles of silver chloride. Okay, now our final step here is we have to look there and we have to look there. We've determined how many moles of a given product would be produced, assuming that each of the reactants could be limiting. And since we know the concept of limiting reactant means it runs out first, out of those two numbers with the red star, whatever one is less, is smaller, that is the limiting reactant. So whatever reactant produces fewer moles of product is limiting. All right, whatever reactant produces fewer moles of product is limiting. So this one, we can tell that this is a smaller number than this one. So that means that KCl, or potassium chloride, is the limiting reactant. And silver nitrate is in excess. Alright, so that's how we would approach one example of determining the limiting reactant for a reaction involving precipitation or neutralization that has solutions. So this is the same concept from a previous unit, and it's the exact same skill that we had already worked on. The exact same, only difference this time was it was just a slightly different method of finding the moles. But otherwise it was the same, right? We start with our balanced equation. We find the number of moles of each reactant, right? Then we use stoichiometry to compare the moles of each reactant to the same product. We assume, right? So here we're assuming how many moles of the same product would be produced, assuming each one were limiting, and the one that actually produces less, theoretically, is limiting.